All around us, often completely unnoticed, exists a bustling and hidden world. It is a world of immense cooperation, incredible strength, and tireless industriousness. This is the world of the ant. These tiny creatures, so often overlooked as we walk through a park or our own gardens, are among the most successful organisms on the planet. They've colonized nearly every landmass on Earth, from the densest rainforests to the driest deserts, adapting to environments as extreme as Arctic tundras and urban concrete jungles. They are social insects, which means they live together in large, organized groups called colonies. This communal life is a secret to their remarkable success, allowing them to accomplish feats impossible for any single individual, such as lifting objects many times their weight or constructing vast underground networks. An ant is not just a simple insect. It is a marvel of natural engineering. Its body is divided into three distinct parts: the head, the thorax, and the abdomen. On its head, you'll find a pair of powerful mandibles used to cut, carry, and defend with precision. They also have two antennae, and these are not just for show. These are their primary sensory organs, allowing them to smell, touch, and even taste the world around them, detecting chemical cues with astonishing sensitivity. The thorax, the middle section, is where their 6 strong legs are attached, propelling them across vast distances relative to their size, sometimes covering the equivalent of human marathons in a single day. Finally, the abdomen contains their vital organs, and in some species, the formidable stinger capable of delivering painful venom to deter threats. But the true power of ants lies not in their individual anatomy, but in their collective identity. A colony is more than a collection of ants. It is a superorganism, functioning as a single entity with a shared purpose. Within this superorganism, each ant has a specific role to play, a task that contributes to the survival and prosperity of the entire community. There are the workers who tirelessly forage for food, maintain the nest, and care for the young. There are the soldiers, larger and stronger, tasked with defending the colony from predators, rival ants, or even invasive species that threaten their territory. And at the heart of it all is a queen, the most important individual, whose sole purpose is to lay the eggs that will ensure the colony's future. This division of labor is what makes an ant colony so incredibly efficient. Imagine a city where every citizen knows their exact duty from birth and performs it without question for the greater good. That is the reality inside an anthill. They communicate using chemical signals called pheromones, leaving invisible trails that guide their sisters to food or warn of imminent danger, such as an approaching predator or environmental hazard. This silent chemical language unites the colony, allowing tens of thousands or even millions of individuals to act as a single, unified entity, responding swiftly to challenges as a cohesive unit. It is a testament to the power of cooperation, a lesson in unity, written on the forest floor, in the cracks of sidewalks, and across sprawling savannas. The home of an ant colony is far more than a simple hole in the ground. It is an intricate and purposeful fortress, known as a nest or a formicarium. The location and design of these nests are as varied as the ants themselves, tailored to the specific needs of each species and environment. You can find them beneath a simple paving stone, inside a hollow log, or high in the canopy of a tree, suspended among the branches. Some species, like the common black ant, are expert excavators. They move countless grains of soil one by one to create an extensive network of underground chambers and tunnels, sometimes spanning several meters in depth and width. These subterranean cities are built for stability, protection, and climate control, keeping the colony safe from predators, harsh weather, and temperature fluctuations. Constructing these nests is a monumental team effort. Worker ants use their powerful jaws to dig through soil, wood, or sand. They carry each tiny particle slowly but surely, shaping their environment with meticulous care. The internal structure is not random. It is carefully planned. There are specific chambers for different purposes. Nurseries are built to house the precious eggs, larvae, and pupae, often in areas where temperature and humidity are perfectly regulated to ensure optimal development. Food is stored in other chambers, like pantries, ensuring the colony has provisions during scarcity. And deep within the nest, in the most protected chamber of all, resides a queen, safeguarded by layers of tunnels and loyal workers. Not all ants live underground. Weaver ants, found in Africa and Asia, are master tree-dwelling architects. They build their nests high in the trees by binding living leaves together, creating structures that are both functional and resilient. To do this, adult worker ants pull the edges of leaves together, forming a living chain with their bodies, demonstrating extraordinary teamwork. Then other workers arrive, carrying the colony's own larvae in their jaws. They gently squeeze the larvae, which secrete a sticky silk-like thread. This natural silk is used to sew the leaves, creating a safe and waterproof shelter capable of withstanding tropical storms. It is an extraordinary example of tool use in insects, using their own young as living glue guns, showcasing the ingenuity of their collective behavior. The complexity of these structures is astounding. A single underground nest can stretch several meters deep and cover a large area, containing hundreds of interconnected passageways and chambers, some as small as a grain of rice, others large enough to house thousands of ants. These nests are not static. They are constantly expanding and being repaired as the colony grows, with workers tirelessly maintaining structural integrity. Ants maintain ventilation shafts to ensure a steady flow of fresh air and dig drainage tunnels to prevent flooding during heavy rains, demonstrating an innate understanding of environmental engineering. The nest is the colony's castle, its cradle, and its city all in one, a testament to what can be achieved through persistent, collaborative work. Built grain by grain, a monument to the power of collective effort, an ant colony is a living, breathing city. And like any city, it requires a constant supply of resources to function. The task of feeding millions of hungry mouths falls to the tireless worker ants, the foragers, whose efforts sustain the colony's growth and survival. Their diet is incredibly diverse. Many ants are omnivores, meaning they'll eat nearly anything they can find, from sugary sap to protein-rich prey. This includes sweet substances like flower nectar or the sugary honeydew produced by aphids, which ants farm in a symbiotic relationship, protecting aphids in exchange for their secretions. They're also hunters, preying on other small insects and invertebrates, using coordinated attacks to overwhelm larger prey. And they're scavengers, efficiently clearing the forest floor of dead animals and fallen fruits, playing a vital role as nature's cleanup crew, recycling nutrients back into the ecosystem. Foraging is a highly organized operation, not random wandering. Scouting groups are sent out from the nest to explore the surrounding territory, covering vast distances relative to their size. When a scout discovers a promising food source to fallen crumb, a drop of juice, or a dead beetle, she faces a challenge of communicating this discovery to her nestmates. She does this by laying down a pheromone trail. As she returns to the nest, she presses her abdomen to the ground at intervals, releasing a unique chemical scent specific to her colony. This invisible trail acts like a map, a chemical breadcrumb path that other workers can follow directly to the prize, ensuring efficient resource collection. This chemical communication is remarkably sophisticated. The strength of the pheromone trail can indicate the quality and quantity of the food source. A particularly rich find will cause a scout to lay a stronger, longer-lasting trail, recruiting a greater number of workers to help carry the reward, optimizing the colony's efforts. As more ants travel back and forth, they reinforce the trail with their own pheromones, creating a busy highway of activity, a living supply chain. You can often see these ant trails as straight, determined lines of workers marching across a yard or up a tree trunk, all following the same invisible chemical road to a shared goal, a display of unity and purpose. Some ants have developed even more specialized methods for collecting food. Leafcutter ants of the Americas, for example, don't actually eat the leaves they carry so diligently. Instead, they are farmers. They take the leaf fragments back to their underground nests and chew them into pulp. This pulp becomes a substrate for cultivating a specific type of fungus, grown in carefully tended chambers. It is this fungus grown in vast underground gardens that feeds the entire colony, providing a stable food source year-round. They are farmers, tending their crops with the same care as any human cultivator. A partnership between insect and fungus evolved over millions of years, highlighting complexity of their ecological relationships. The life of an ant colony revolves around one unique and vital individual, the queen. Unlike the sterile workers, the queen is the reproductive heart of the community. She may live for many years, sometimes even decades, and her primary all-consuming purpose is to lay eggs, ensuring the colony's continuity. At the peak of summer, a healthy queen can lay thousands of eggs each day, each one a potential contributor to the colony's success. Most of these eggs are unfertilized and will become workers, the backbone of the colony, responsible for its day-to-day operations. But at certain times of the year, the queen will also lay fertilized eggs, which have the potential to become new queens and males critical for the colony's expansion. The creation of a new colony begins with a spectacular event known as the nuptial flight. On a warm, humid day, virgin queens and winged males, known as alates, emerge from their natal nest in a massive swarm, filling the air with activity. They rise into the sky, where they mate in midair, a fleeting but critical moment in their life cycle. For the males, this is their only purpose. Their lives are short, and they die soon after mating their role complete. Newly fertilized queens, however, are just beginning their epic journey. They land, shed their now useless wings, and strike out alone to find a suitable place to establish a new kingdom, a solitary quest fraught with danger. Once a young queen finds a safe location, she digs a small chamber, seals herself inside, and begins laying her first batch of eggs. This is the most vulnerable time in her life. She does not eat, instead surviving on her fat reserves, and by breaking down her now redundant flight muscles, a remarkable feat of self-sacrifice. She alone cares for her first brood, feeding the larvae with her own saliva until they develop into the colony's first workers. These initial workers, known as nanitics, are smaller than average, but they are crucial to the colony's survival, taking on the first tasks of foraging and nest building. As soon as the first workers mature, the queen's role shifts. She withdraws from all other tasks and dedicates herself solely to egg laying, becoming the colony's reproductive engine. Her daughters now take on all duties of foraging, nest maintenance, and caring for subsequent generations, building the foundation for growth. The colony begins to grow, slowly at first, and then rapidly as the workforce expands, transforming the nest into a bustling hub of activity. From this lonely, dangerous beginning, a new empire can emerge. A single queen, through her incredible resilience and dedication, can give rise to a thriving metropolis of hundreds of thousands or even millions of individuals, ensuring the continuation of her species and leaving a lasting mark on the ecosystem.